Lesson 12 is called Quadratic Functions, and in this lesson we're going to be looking at kind of different ways to rework quadratic functions in order to be able to find their zeros. And we've learned these methods in the past when we were learning about solving quadratic equations. They're the methods like factoring and completing the square and the quadratic formula. So I've included throughout the notes kind of example or review videos of each of these strategies to kind of refer back to if you want a little bit more of a refresher than what's in this video. So the first method we're going to talk about is factoring, and there's different types of factoring, but for this lesson we're going to focus on how we factor when there are only two terms in your quadratic, or if there's three terms in your quadratic. There's another one that happens if it's like four terms, and that would be factored by grouping. If we have two terms in our quadratic, then we're looking for something that's called a difference of squares. And a difference of squares is one perfect square minus another. So our formula for a difference of squares is right here. The original problem would be given in the form a squared minus b squared, and we would factor it into a plus b times a minus b. We're going to use that formula down here under example 1a. Before we do that, I'm going to move over to the three term side. There are a few different methods that you can use to factor when your quadratic has three terms. There's the decomposition method. That's what we learned a few months back. And then there's also something called the X method, which we're going to talk about today. That's something that we haven't talked about in the past. So for the X method, there's kind of like an initial setup that you need to get comfortable with. And before we get into the setup, we just want to kind of review like what is standard form of a quadratic. And standard form of a quadratic is ax squared plus bx plus c equals 0. So really anytime we're factoring, we want our equation to be in that form. And what it is referring to is the x squared term would come first, and then the one with x would go second, and then the constant term with no x would go third, and then the other side of the equal sign would be a 0. So once you have your equation in that correct order, the X method is called the X method because we draw like a big X. And then on top of the big X, we're going to take A and C, whatever those numbers are, and multiply them. So like A will be the number in front of X squared, and then C will be the constant term, the number that doesn't have a variable. Those will get multiplied together on top of the X, and then B will go on the bottom of the X. And b is the number in front of x in your quadratic, the coefficient of x. And then once we have those numbers filled in like at the top and at the bottom, we're going to end up looking for a combination of numbers that multiply to our top number and add up to our bottom number. Once we find those two numbers, they would go on the left and the right side of the x. And then once we have those numbers on the left and right side, we would create a fraction. And then we'd put a in the bottom. And then the number in the denominator is going to end up being the coefficient of x when we write our factors. So I'm going to add a little x in there. So this whole thing does not have to mean anything to you yet, and it probably shouldn't because we haven't actually gone through the example. But you just need to kind of copy down like exactly what this looks like so that you can refer back to it for an example once we get into the problem. So again, if it's confusing right now, it's because you don't really know what to do with it yet. It's just almost like a formula kind of. Okay, so for example 1, it says find the zeros of each function. And when something says find the zeros, that means that we take a 0 and we put it in for f of x. So instead of f of x equals, we would change it to 0 equals 4x squared minus 25. And then now we want to factor. So in order to before we start factoring, we want to see how many terms we're factoring. And we just look at like what is on the side that doesn't have the 0. So there's one term right here, 4x squared, and then the minus 25 is a second term. So that has two terms, so we're going to use this difference of squares formula for it. So in order to use that formula, it's really helpful to rewrite the 4x squared and the 25 as like what quantity is being squared to get that number. So I'm actually going to start with the 25 because I think it's a little bit easier to make sense of. So 25 is 5 squared. So I'm going to rewrite 25 as 5 squared because 5 squared means 5 times 5, which is 25. The 4x squared, anytime you have like a number in front of x, you need to rewrite it in parentheses, squared. And then like as it's written right now, only the x is being squared. But we have to think of like what number squared equals 4. And 2 squared equals 4. So when we rewrite it in parentheses, it would be 2x squared. Because what this means is like 2 squared and x squared, which would simplify back to 4x squared. So from here to here, we're not like changing the value at all. We're just rewriting it in that form. And the reason that we do that is because now that number in front that is being squared, that's going to be our a. So our a is going to be 2x. If we say a is 4x, that would end up giving us the wrong answer. And then the second number, like the one after the subtraction symbol that's being squared, that's going to be our b. So our b would just be 5. And then now we just need to fill in a and b into the second part of this formula right here. So like a is 2x, we're going to put that in for both of the a's, and then b is 5, we'll put that in for both of the b's into this portion of the formula. That portion is going to give us our final answer. So this would be 0 equals a plus b, so 2x plus 5. And then a minus b, so 2x minus 5. So we put 2x in for both of the a's and then 5 in for both of the b's into this formula up here. And then when it says find the zeros, we have to go all the way down to like where we get x equals 0. So next we're going to use something called the zero product property, and that requires us to take each factor. So this is one factor right here, 2x plus 5, we're going to set that equal to 0. And then the second factor, which is 2x minus 5, we're going to set that equal to 0 as well. So 2x minus 5 equals 0. And then now we have to solve each one of those like kind of mini equations for x. So I'm going to start with this one right here. If I'm trying to solve for x, I have to cancel the things out that are being done to it. So to cancel out that plus 5, I would subtract 5 from both sides. And then I would bring down the 2x. And then 5 minus 5 cancels out. 0 minus 5 is negative 5. And then now I still need to get x by itself. I have a 2 that's being multiplied by x, so I would have to divide both sides by 2 to cancel it out. And then I would be left with x equals, because 2 divided by 2, those would cancel. I'd just be left with 1x, or just regular x. And then over here I have negative 5 over 2. So x equals negative 5 over 2. And that's one of my zeros, and I can just leave it as a fraction like that. And then I'm going to move over and do pretty much the same thing with that second equation. So we're trying to get x by itself. I have to cancel out the things that are being done. So now I have a 5 that's being subtracted. So the opposite of subtracting 5 would be adding 5. So I'm going to add 5 to both sides. Bring down the 2x. Negative 5 plus 5 would cancel out. 0 plus 5 is 5. Still trying to get x by itself, so I have a 2 that's being multiplied by x, so I would have to divide both sides by 2 again. 2 divided by 2 cancels each other out, so I'm left with just x, and then equals, over here I have a positive 5 over 2. So this one would be x equals positive 5 over 2, or positive 5 halves. I'm just going to write my final answers up here, so x equals negative 5 halves. And x equals positive 5 halves are my like final zeros for this problem. Okay, so moving over to b, it's f of x equals 6x squared plus 5x, and the instructions are the same. It says to like find the zeros, so that means that we're going to put a 0 in for f of x. So it'd be 0 equals 6x squared plus 5x minus 6, And then on this problem, on that other side of the equal sign, I have 1, 2, 3 terms. So if I have 3 terms, I can use the decomposition method or the X method if I want to. I'm going to show the X method for this one. But ultimately, you can kind of decide which one you prefer. So I'm going to go through and label like what is A, what is B, what is C, based off of standard form right here. So A is the number in front of x squared, so A is going to be 6 for this problem. B is the number in front of x, so B is going to be 5. And then C is the constant, so that's going to be the number with no x, that'd be negative 6. And then I'm going to draw my big X, and I'm going to use kind of like how all these numbers are set up to kind of set up my x for this actual problem. So at the top up here, it says A times C. So that would be 6 times negative 6, because A is 6, C is negative 6. We're just going to go ahead and actually put the simplified version up there though. I just wanted to show where we're going to get that final number. So instead of like leaving it as 6 times negative 6, 6 times negative 6 is negative 36. So that's what the number I'm going to put up there is. And then at the bottom of the X, we're supposed to put B. So B is 5. And then you can see on like the top part of the X right here, it says we're supposed to multiply. At the bottom, we're supposed to add. So what that means is that we want to find a pair of numbers that would multiply to negative 36, but add up to 5. So I think the best way to approach it is to make a list of all the numbers that you can think of that multiply to 36. So for my factors of 36, and I'm not going to worry too much about the negative yet, but 36 can be 1 times 36, 2 times 18, 3 times 36, 4 times 9, or 6 times 6. So now if I need to multiply to a negative 36, one of my numbers will have to be negative, because a positive times a negative would give me a negative. And then I also need to find the pair that would add up to a 5. So since one of my numbers will have to be negative, I really want to look for the pair of numbers that has a difference of 5, and that's going to be 4 and 9. And if I want them to add up to a positive 5, I have to make the smaller number negative. So I'm going to do negative 4 and positive 9. So it doesn't matter which side you put them on. It'll be negative 4, positive 9. And then right here it says we need to put A in the denominator, or A times X. So A is going to be 6. I'm not going to worry about putting the X there yet. I'm going to do it in a second. But if we have a fraction we can reduce, you want to reduce it. So like what that means is 4 and 6 are both divisible by 2. So I'm going to divide those both by 2 to reduce that fraction. Negative 4 divided by 2 is negative 2. And 6 divided by 2 is 3. And then now that it's reduced, I'm going to put the X there. And then for the 9 and the 6, those are both divisible by 3. So 9 divided by 3 is 3, and 6 divided by 3 is 2. And then now that they're both reduced, I'm going to put the X on the bottom. The X always goes on the bottom. And then, believe it or not, these are actually going to be our factors, and we just write them from the bottom up. So like this is going to be a 3x minus 2, and we'll put that in parentheses, so it'd be 0 equals 3x minus 2. And then the one on the right, it's 2x. And then we don't have a number in front of the 3, or a sign in front of the 3, so that means that it's positive. So that'd be 2x plus 3, since it's a positive 3. And then now our equation is in factored form, so we can go ahead and set each factor equal to 0. So one factor is 3x minus 2, so it'd be 3x minus 2 equals 0. And then the other factor is going to be 2x plus 3. So we can set that equal to 0, 2x plus 3 equal to 0, and then now we just solve each of those two equations separately. So I'm going to start with this one. If I'm solving, I'm trying to get x completely by itself. So I have to cancel out that minus 2 by adding 2 to both sides. And then I would bring down the 3x. Minus 2 plus 2 cancels out. 0 plus 2 is 2. Now I need to cancel out the 3 that's being multiplied by the x, so I would divide both sides by 3. 3 divided by 3 cancels out, so I'd be left with just x equals 2/3. It's going to be one of my zeros. And then for the second equation now, 2x plus 3. If I'm trying to get x by itself, I need to cancel out that plus 3 by subtracting 3 from both sides. So I'll bring down the 2x. 3 minus 3 cancels out, and then equals 0 minus 3 is -3. And then now I need to cancel out the 2 that's being multiplied, so I'll divide both sides by 2. So I end up with x equals -3 over 2, or -3/2. So my 0 for example 1b, or my zeros, are x equals 2/3 and x equals -3 over 2, or 3/2. Okay, moving down to example 1 of the next section, which is completing the square. So completing the square is another kind of like strategy that we can use to rework quadratic equations or quadratic functions. So you'll see the instructions are the same. It says find the zeros of f of x equals 0, x squared minus 12x plus 11. So I would have to, I don't know if I said that right, but f of x equals x squared minus 12x plus 11. I don't know why, it feels like I kind of said it wrong the first time, but just in case. That means we're going to put 0 in for f of x. So it'd be 0 equals x squared minus 12x plus 11. And then for this one, now we're just going to follow these steps, step 1 through 4, to find the zeros of this equation by completing the square. So step 1 says make sure your equation is in the form ax squared plus bx equals d. And what that means is that if you have a constant in your equation, it goes on the other side of the equal sign from the other two terms, the x squared and the -12x. So what I'm going to do so it looks exactly the same is you'll notice this has the d on the other side of the equal sign on the right. I'm going to move my 0 over there. So it's okay. It's totally okay if we do that. Instead of putting equals 0 on the left side, I'm going to move it over here. It doesn't change the value or anything. And then now I need to figure out a way to cancel out that 11 and move it to the other side so that I just have this x squared minus 12x on the left side of the equal sign. So to cancel out that plus 11, I'm going to subtract 11 from both sides. And then I'll bring down my x squared minus 12x. 11 minus 11 cancels out, and then I have equals 0 minus 11, so -11. And then step 2 says find b over 2 squared and add it to both sides of the equation. So b is this b right here is referring to the number in front of x. So in our equation, b is going to be -12. So I need to take that little formula. I'm going to do it off to the side here. So it's b over 2 squared, and I'm going to put a -12 in there. So it's going to be -12 over 2 squared. And then I'm going to bump it down here so I don't kind of run into my equation. But -12 over 2 means -12 divided by 2, so that's -6. And then -6 squared means -6 times -6, so that's +36. So +36, that's going to be the number that we have to add to both sides of the equation like it says to do right here. So we're going to add 36 after the -12x, and then also over here on the other side of the equation after the -11. So that would be x squared minus 12x, and then plus 36 right here, and then equals -11 plus 36 right here. And then now we're moving on to step 3, and step 3 says to factor your trinomials. That's referring to these 3 right here. So when we complete the square, every time we go through this process of adding b over 2 squared to both sides, our trinomial always factors into a binomial squared, which means I can rewrite that line as something in parentheses squared, and then we can factor it using a certain pattern. So the pattern is you take the square root of the first term, so the square root of x squared is just x, and then you take the sign from the middle term, only the sign, so since that's a minus, we do a minus, and then we take the square root of the third term, so the square root of 36 would be 6, because 6 squared, 6 times 6 equals 36. And then equals negative 11 plus 36, we can add those two together to get 25. And now we're done with step 3. And then for step 4, it says square root both sides of the equation and solve for x. I'm going to go ahead and just rewrite the line I have up here without the highlight on there. So it's x minus 6 squared equals 25. And then now I'm ready to square root both sides to solve for x. So we square root the left side to cancel out that exponent, because square rooting something cancels out like raising something to the second power. So that would leave me with just x minus 6 only, no more exponent. And then the square root of 25 is going to be 5, because 5 times 5 equals 25. But it can also be negative 5. So we would write it as positive or negative 5. And the reason is because, yes, like 5 squared is 5 times 5, so that's 25. But negative 5 squared, that means negative 5 times negative 5, and negative 5 times negative 5 is positive 25 also, so we have to include both. And then now that we have our like square root done, we need to kind of create two different equations to find, because we're going to have two different answers. So one of them is going to be, we do x minus 6. One of them is going to be set equal to the positive 5. So we would do x minus 6 equals positive 5. And then the other one is going to be x minus 6 and set it equal to the negative 5. Because it says it can be equal to positive or negative 5, so we need to do both. So one is equal to the positive 5, one is equal to the negative 5. And then now we want to solve each one for x separately. But we just need to do the same thing to each side. So we need to like cancel out the minus 6 to both, because the like only thing that's being done to x is 6 is being subtracted from it. So we need to cancel it out by adding it. So we would do x, and then negative 6 plus 6 would cancel out. 5 plus 6 would give us 11, so that's going to be one of the zeros. And then the second equation, x minus 6, so I'd have to cancel out the minus 6 by adding 6 to both sides. We bring down the x. Minus 6 plus 6 cancels out, and then negative 5 plus 6 is 1. So our zeros for this one, for like the completing the square problem, are going to be x equals 11 and x equals 1. Okay, moving down to the last method for solving quadratics is the quadratic formula. And just a quick, I know we talked about it earlier in the lesson, but we need to know standard form of a quadratic for this problem, and it's standard form is either 0 or f of x equals ax squared plus bx plus c, where a is the number in front of x squared, b is the number in front of x, and then c is the constant that has no variable. So example 1, show the zeros of, or find the zeros of f of x equals 2x squared minus 7x minus 13 using the quadratic formula, which is over here. It's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so find the zeros means we put 0 in for f of x. So it'd be 0 equals 2x squared minus 7x minus 13. We need to figure out what a, b, and c are. So a is the number in front of x squared. B is the number in front of x, so negative 7. And then c is the number with no x, so that would be negative 13. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac, and then all over 2a. So we figured out from our equation that a is 2, that's this number right here. It's the number in front of x squared, the coefficient, so we'll put 2 in right here and right here. And then b is negative 7, that's the coefficient of x. So we'll put negative 7 in right here and right here. And then c is the constant, so that's 13. negative 13, excuse me. So we're going to put negative 13 in right here for C. So in front of, I think I'm actually going to just like maybe erase the like letters and kind of substitute them in to that original formula since we have the formula written up above. So in that first spot where there's a B right here, I'm going to take that out and I'm going to put a negative 7. But that negative that's out in front is like a part of the formula. So it's going to stay there and it's going to be a double negative. You'll see there's a negative, negative 7. And then there's also a B right here in front of the like little exponent. So I'm going to take out that B and put a negative 7 there. And then where the A's are, I'm going to take out those and put 2's in because A equals 2. So we'll take that out, put a 2 in, take that out, put a 2 in. And then for C, C goes right here, and C from the problem is negative 13. So I'm going to take out that last little C and put in a negative 13. And then now we can start simplifying. So I'm going to draw my line. Right here, negative, negative 7. If you have a double negative, that turns into a positive. So this will turn into a positive 7 plus or minus the square root. Oops. The square root of negative 7 squared, that means negative 7 times negative 7. So that would be positive 49. And then the next part of the problem is where the most mistakes are made. So what I would recommend is I would count your negatives. So we have 1 for the like minus 4 times 2 times 13 part. You have 1, 2 negatives. If you have an even amount of negatives, you will have a positive product. So I'm going to put a plus right here. And then now I can just multiply 4 times 2 times 13, and I don't have to worry about the signs because I already counted my negatives and they're an even amount. There's 2 of them, so I'll have a positive outcome. So I'm just going to do 4 times 2 times 13, and that's 104. And then over in the denominator, I have 2 times 2, so 4. So if you count an even amount of negatives, it's going to be a positive product once you multiply them. If it's an odd amount of negatives, you would have a negative product. And then now I can go ahead and add the numbers inside of my radical. So it'd be 7 plus or minus the square root of 104 plus 49 is 153. And then in the denominator, I have just that 4 there. And then that's our final answer. So the zeros of this problem are going to be x equals 7 plus or minus the square root of 153 all over 4. And this represents 2 different answers because it can be, it could be 7 plus the square root of 153 over 4. Or it can be 7 minus the square root of 153 over 4.